Hello everybody, welcome back to the Sunday afternoon episode of How to Build an F-14 Tomcat. I know last video I said I wasn't going to do another video, but I got done a little early. Figured, hey, let's do another video for you guys. So you can see I've got both wing cores for the top and bottom left wing panel cut out for the core material. I've got a bunch of carbon fiber. I've got 4 layers of this papered stuff cut out. I got 2 here, and I got 2 up under this core here, and I've also got 4 more layers of some narrower stuff there. So figured you guys also went ahead and primed up both wing panel molds. So the primer is drying now, and yep, pretty much we're getting closer to being ready to lay up a wing panel. Just got to get some carbon fiber toe in here, and we'll be good with this wing to go. Figure you guys might like to see kind of what I'm thinking as far as wing structure and everything. I already pointed out all the carbon fiber. That's some pretty heavy unidirectional stuff. I've got it in like a 6-inch wide piece of tape, and I just cut it down to those 1-inch wide pieces there, and then the tapered stuff right there and there. I have shown you guys, I believe, my little machine bearing holder here for the wing panels. This actually gets captured inside the wing forever and ever, hopefully never to be seen again. And probably wondering how this is going to be enough for the wing, and how this little piece of aluminum is going to do anything, and how the wing forces are going to be transferred to this, and blase, blase, blase. That's where the carbon fiber comes in, and the wing cores, and then the carbon fiber toe. Where to begin? Because it's all in my head, and it's pretty hard to explain in words without actually being able to, well, you'll kind of be able to see it. So looking at the wing core here, we have with the unidirectional carbon under it. Everywhere you see carbon coming through, including up here where you can't. Let me zoom in for you guys so you'll get a better understanding. Alright. There we go. Get the camera exactly where I want it. We'll be good to go. Alright. So everywhere you see this hole right through here in the wing core is going to get packed full of carbon fiber toe. And you're like, okay, great. So that'll end up being our spar cap there. And then this unidirectional cloth will be both under the core and on top of it, and it'll be sandwiched, and then there'll be glass cloth on either side of that. And then we've got our little bearing holder here. Can't see it because the tape's kind of blocking it. So what I'll do is I'll bring you guys down to the other core, which you can see some lines drawn out, some kind of semicircles and a circle, and the slots and my table surface under it. So what we'll do is this little aluminum bearing holder will actually pierce through the core right here. And everywhere this this half circle right here that's not cut out, once this core is inside the wing panel, I'll cut that out right before I lay it in. The core will go down, and then everywhere in this slot is going to get packed full of carbon fiber toe, like I said. So what happens is this carbon toe goes all the way from the wingtip all the way up around. And it goes around our bearing holder and back down to the wingtip. And since the carbon toe splits off a little bit, whoops, since the carbon fiber toe splits in half, basically right at this point, we'll actually, if we just keep going with the same amount of carbon toe the whole length, we'll actually end up with a thinner piece, thinner spar cap here than down where it joins together. So more carbon toe will get placed in this triangular section that you see that's opened up. And then all that will get back and back down, and that'll be our wing skin with our wing spar cap integral to the wing skin. After that, when we go to do our internal structure, this is where that kind of the Y, or the split in the road with the spar cap, comes into play. Originally, I had planned to just have a single shear web that butted up right to the center of the pivot bearing, and then it would run all the way down the center of the spar cap, all the way to where the wingtip would start. After looking at it and seeing how everything's going, that would work fine, because this pivot bearing area is really close to the root rib, so it's going to have a lot of support there, sort of. So what I've decided to do, instead of just a single shear web, is a single shear web will come all the way up to the bearing bracket here, or the pivot bearing holder, and then it'll get glassed around the bearing and to the holder. And then where it splits, I'm going to have two more shear webs that epoxy up to the main center shear web, and then they also get glassed to the shear web, and then they run all the way up flush to the sides of the bearing holder, and then straight into the wing root rib and the wing skin. So what this is going to do is it's going to sit there, and the center one's going to provide all your shear web, all your shear loading. The spar cap's going to take all your bending loads, hopefully, and then these other pieces that come up across, they're going to encapsulate and sandwich this bearing holder to keep it from twisting forward and backwards and just moving, period. And then I'll probably have I'll get some foaming epoxy and some carbon fiber or something, and I'll figure out some way of encapsulating this whole thing into a really nice solid area into the wing rib and this whole shear web area. So that's my thinking on the on the whole wing spar setup. Like I said, I've done some Suedo CAD drawings and kind of tied all this stuff in. I've done just the spar caps and everything, and the way I've got the spar set up with the shear web and the spar cap, the same width, thickness, same material and everything, the wings should hold up fairly well. And I'm actually, this unidirectional cloth I'm planning on using is actually heavier than what I originally planned on using for the wing. The reason why I'm using this is because I've got it, and on this prototype wing it'll save me a little bit of money. It's a heavier duty, a heavier weight carbon, and it's a little bit, I think it's a little lower modulus carbon as well, so it's a little stronger but not quite as stiff compared to what I was planning on using. So it'll bend a little bit more because it's heavier. The extra weight of it will make it just as strong as the other stuff I had planned on using. And if this wing panel comes out with the strength that I'm looking for, which again I'm wanting this single wing panel bolted to the table or whatever, a C-clamp, a vise, the back of a 757. Just kidding. I want a single wing panel to hold between 300 and 400 pounds of weight. Again, the F-14 fuselage produces a fairly significant amount of the lift for the airplane compared to the wings. I think it takes up something between 30 to 40% of the lift. So if you've got a 65-pound airplane, somebody do the math, what's that? 10, 6, about 20 pounds of lift roughly that the fuselage is producing. So that only gives you another 20 pounds of lift roughly per wing panel. So if you've got 300 pounds of force on one wing, that's about 10, 12, 13 G wing loading. Again, my math in my head's not the greatest, so if the numbers are wrong, forgive me. I'm not a math genius. But again, I mean, a 10 G wing loading on one wing panel, that's pretty significant. I mean, now you're talking about spread it over the fuselage, wings, and 2 wing panels. So I'm building this wing panel to last. This airplane is being built to be flown. It's not going to be a hangar queen. If you can't fly it like the real one was flown, it has no reason to be in the sky. So a little extra weight. If my calculations are right, a one wing panel should be about 3.5 to 4 pounds, not including the flap. I don't suspect the flap to weigh much more than half a pound. So you're talking about 5 pounds per wing. I know it sounds heavy. The built-up wing that I did for the plug weighs 2.5 pounds without the flap, and that's covered in aluminum. So and that wing wasn't really built to be flown hard. I'd be surprised if that thing even lasted long enough to get off the ground. It's very lightweight, and the whole spar structure and everything is very weak as they're drawn on the plans. But again, 5 pounds per wing panel, 10 pounds total for the wings. If it'll hold 300-400 pounds of weight, I'm fine with that. I mean, the airplane's not gonna weigh 25 pounds ready to go. If it comes in 65 pounds ready to go, I'll be happy. So that's where we're at. You can see I've got the whole monkey motion with the spoilers on the one core. That was kind of fun to deal with. So that's where I'm at right now. Again, until I get materials, I'm kind of in a holding pattern. But hopefully next weekend we'll be closing up some vertical fins and laying up some wing panels. So once that's done, and once I get one wing panel laid up and I get it stress tested and it performs the way I want to, I pretty much have very little. The only reason I'd have not to do a fuselage and the other wing panel very quickly is money. But those are really this one wing panel is going to tell everything, because if it works out great, it's going to be afterburner getting one of these things ready to go. And if this wing works out well and it stress tests is fine, I'll keep it as it is, and this will be a flying wing. If I hear any cracking or buckling or anything that I don't like, I'll lay up another set of wing panels, and I'll keep going through this process and just using materials on one wing until it'll hold what I'm expecting it to. And again, this airplane is going to be built to flown. I'm not gonna mess around and try and keep it light. I'm gonna keep it reasonably light, but I'm not gonna make it stupid light just to sell more numbers. This is gonna be something that you build it, you fly it, and you hold on to it for a while. As long as you can maintain it like you should with these things, she'll last you forever. So there we go. Now y'all kind of have an insight into the mind ramblings of either a genius or a crazy man for even thinking about doing something like this. But again, main spar, and then these little 1-inch strips of unidirectional here will go along the trailing edge of the wing, and I'll have a secondary spar back there as well that will also act as a wing spar, and it'll also key in for the flap hinge mechanisms and everything. I've got a nifty way of doing the flap hinging on this to make it scale, but easy to hinge scale. And it's going to involve some CNC routed parts out of G10 and some stuff, but if it works out how I think it is, it's going to be awesome, because it'll save you a ton of work in hinging the thing. It'll basically be gluing a couple of pieces together, sticking some hinge pins in it, and gluing it to the wing, and you're done. I got lots of ideas to make this an easy, even though it's going to be an ARF kit is what I'm going to call it. It's going to be a quick build. A lot of this stuff is going on already. Got some quotes on some of the machine parts for the horizontal stab, and I am, put it lightly, I fell out of my chair when I saw it. Let me grab a couple parts and I'll show you guys what I was quoted. To give you a good reason, it'll give you more of an insight on why this stuff's so flipping expensive. Alright, so this is the horizontal stab, the pivot holder, and the servo mount. This servo mount, I mean, it's nothing fancy, just a bar of aluminum, then you mill it down and cut some holes and stuff in it. I know I'll make it sound a lot easier than it probably is, but when everything's CNC, it should be fairly simple. This one servo mount, they want $900 for one of them. If I order 10,000 of them, I can get them down to sub $200 a piece. But I don't need 10,000. I don't even need 1,000 of them. I'd be lucky if I need 200. So that was what they're quoting on that. This little pivot shaft holder, Yeah, they want like $400 for one of those. And the more I see how insanely expensive these machine parts are, the more I'm thinking this stuff is going to get carbon fiber reinforced plywood to hold it. Yellow Aircraft, they use some really high grade quality aircraft plywood on all their rear bulkheads, and this is on their big F-18 twin. I mean, that airplane comes in 55 pounds ready to go with turbine power, twin turbines I think. But again, they use a really nice quality aircraft grade plywood. They make a box that's sandwiched between two bulkheads, and it holds two ball bearings, basically just like this would be done. But it's all plywood, not even carbon reinforced plywood. It's just straight plywood, and that works out fantastic for them. And then their servo mounts are all a really high quality plywood as well. So if I can't find a reasonably priced one of these out of aluminum, this will all get transformed into a wooden setup with some carbon fiber parts or carbon fiber reinforcement, and that'll cut down on the price of the kit at least by $1,000, I would think, because that will eliminate 4 machine components out of it. So that's where I'm at on this Sunday afternoon, and if everything goes well, I can get my order of carbon fiber and stuff in today. Should have it by Friday. Saturday we'll be making some more videos, maybe even Friday night. Just kind of depends on when that stuff gets here. So until next time, all you guys and gals have a, like I said, good week at work, and we will see you back here in the shop with the Tomcat. See ya.